In this example, we'd like to find the given limit. The problem is you can't input the target value of -1 inside here because you will get 0 on the bottom, and on the top you will also get 0 because you will get -3 plus 28, which will give you 25. Square root of 25 is 5. 5 minus 5 is 0. Right? So you get 0 over 0 if you plug in -1 into the x in the numerator and denominator. And 0 over 0 is considered to be indeterminate form. Indeterminate form means you're going to have to do something else to find the limit. You can't just input it. Right? Indeterminate means you cannot determine the limit that way. 0 over 0 is indeterminate form. So what do? The first thing that I would advise to do is to use the conjugate of the numerator and multiply that to the given numerator and denominator. So what I'm saying we need to do, we need to multiply both the numerator and denominator by the conjugate. And the conjugate of the numerator is going to be 5 plus the square root of 3x plus 28. Right? So conjugate usually just means that you're going to replace the signs in between two terms, usually. So 5 minus will give you 5 plus. That would be the conjugate. All right? And that way, why is it important? It's important because we want to get rid of this trouble on the top. Right? We want to get rid of this square root on the top. We're kind of rationalizing the numerator, sort of, right? This is called rationalizing the numerator in order to get rid of the trouble x being on the top, and in fact x producing 0 on the top. We don't want x to produce 0 whenever we plug in -1, right? We want to get rid of that. Notice that we're not changing the quantity itself, we're just changing the way it's going to look. It's going to be essentially the same because this thing is equal to 1. That's the beauty of applying it both to the numerator and denominator, because this thing is equal to 1, and each fraction that you see is always multiplied by 1. Because 1 doesn't change the quantity. Anything times 1 is that same quantity. It doesn't change. Right? So now as a result, using the FOIL method for the top, you realize you will have 4 products. 5 times 5 is the first. 5 times 5 is the first. Thus you will get 25. The second product is 5 times the square root with a plus sign. The third product is minus sign with 5 times the square root, so we can cross it out because it's going to cancel itself, right? The second and third products give you 2 terms that cancel each other out and give you 0 that way, and we don't need to even write them out. And the last product will be negative with a positive of a square root of the same thing. So that means it's going to be a net minus sign because of the minus times the plus. And then square root times square root gives you basically the inside without the square root, right? It's the same thing as squaring it, right? So it's just 3x plus 28. Be sure that you write parentheses because this minus applied to the entire quantity inside the square root, right? When you square it, there are still parentheses of what you get, and the minus applies on the outside of it. And this will be divided by, what do we get here? What I would advise to do is to leave it like this for now. X plus 1, and then 5 plus square root of 3x plus 28. I would just leave it the way it is. I wouldn't touch that. Let's see what happens after that. So we will get 25 minus 3x minus 28. Minus 28. So we can distribute the minus and we can write it as 25 minus 3x minus 28 divided by this, x plus 1 times 5 plus square root of 3x plus 28. So what this gives us, it gives us minus 3. It gives us minus 3 minus 3x on the top, and x plus 1 times 5 plus square root of 3x plus 28. And now we can take out the minus 3, as you can see, You can take out the minus 3 and write it as like this. 1 plus x, right? Because 1 plus x minus 3 is the GCF of these two terms. It can be taken out. And then 1 plus x is what you need in order to get the first term to be minus 3 and the second term to be minus 3x, right? And that's what it is. And then here we get, of course, as usual, x plus 1 times 5 plus square root of 3x plus 28. Okay, and now guess what happens? The 1 plus x cancels out with the x plus 1 there. And that's the reason why I asked you not to distribute, to leave it alone in the bottom, because you would need that. 1 plus x cancels out with x plus 1. And notice that addition is commutative, right? You can add terms in however order you like. You can write 1 first, you can write x after, you can write x first, you can write 1 after. That's the same thing. It doesn't change the quantity, just like multiplication. Addition is commutative. So as a result, we get only minus 3 in the top. So minus 3 on the top, and here we get no x plus 1 anymore, so we get 5 plus square root of 3x plus 28. And now guess what happens? Now we can plug in the value of negative 1, because not only that, we also have 5 plus, right? If we had 5 minus, we would be in trouble, but it's possible to find a limit in this problem, so it's guaranteed it's going to work out. So 5 plus makes sure that we're not going to get a 0. So if you plug in negative 1, you will get this, negative 3 over 5 plus 3 times minus 3. I'm sorry, minus 1. I don't know why I wrote minus 3, minus 1, plus 28. And that should give you minus 3 over 5 plus minus 3 plus 28 is 25. So that gives you minus 3 over 5 plus 5, which is minus 3 over 10. So this is your limit value. I hope this kind of problem made sense to you. Thanks for watching. See you in the next video.